Hello everyone, here is question number 4 from both the 2025 AP Calculus AB and AP Calculus BC exams. And check out the description below where I provide links to the other 5 FRQs from the AP Calculus AB exam. So number 4 says the continuous function f is defined on the closed interval from -6 to 12, and the graph of f consisting of 2 semicircles and 1 line segment is shown in the figure. And then we have this function g defined as g of x as the integral from 6 to x of f of t dt. Part A asks us to find g prime of 8 and give a reason for your answer. So in order to find g prime of 8, we first have to show g prime of x. And the way you take the derivative of an integral is you make sure the lower limit is a constant, and then you replace the upper limit with t, or you replace t with the upper limit, I should say, and then therefore we would want to state that g prime of x, come down here, that g prime of x is equal to f of x. You do need to state that part, and then from there we can now find g prime of 8, which is going to be equal to f of 8, and that one we can read right off the graph of f and can now state that that value is 1. For part B, we are asked to find all values of x between -6 and 12 at which the graph of g has a point of inflection. So you do need to recall what a point of inflection is, and that is where g prime changes from increasing to decreasing or decreasing to increasing. So I use the same relationship as part A, that g prime of x is equal to f of x. And again, that comes from taking the derivative of this integral or replacing t with the variable x. And then often we have to multiply by the derivative of this upper bound, but here it's just times 1, so that's not going to change the problem. So once again, I want to find where g prime changes from increasing to decreasing or decreasing to increasing, which means where f of x, or the given graph, changes from decreasing to increasing or increasing to decreasing. And we can see that that would occur at -3, an x value of +3, and an x value of 6. So therefore g has a point of inflection at x equals -3, 3, and 6 because g prime, or f of x, changes from decreasing to increasing or increasing to decreasing. In part C, we need to find g of 12 and g of 0, and we'll make sure to label those answers. Because g of x is defined, I can simply replace the x with 12 here and here to find g of 12, and replace x with 0 both here and here. So let's start with g of 12. Therefore, g of 12 is the integral from 6 to 12 of f of t dt. This means to find the area under the f curve between 6 and 12. And as I come up here, I can see that the area under this curve from 6 to 12 is simply a triangle. And the formula is 1/2 base times height, where in this problem we can see 6 is the base and 3 is the height. Therefore, our answer would be 9. Now let's find the integral, or now let's find the value of g of 0, which means that would be the integral from 6 to 0 of f of t dt. Now, I don't like to have the higher number on the bottom and the lower number on the top, so I do like to switch those bounds, but when I do that, I do need to make the integral negative. So this would be negative integral from 0 to 6 of f of t dt. And you can see from 0 to 6, you have a semicircle, and the formula would be 1/2 pi r squared. So in our case, then, we would have negative, because we switched the bounds of the integral, of 1/2 pi r squared, and you can see the radius right here would be the value of 3. Therefore, that would simplify to -9/2 pi. Moving on to the final part, part D. D asks us to find the value of x at which g attains an absolute minimum on the closed interval from -6 to 12 and justify your answer. As soon as I see a question that asks me to find an absolute minimum or absolute maximum, I know that's going to require me to use the candidate's test. In the candidate's test, we test both critical points and endpoints because those are the only places where your absolute minimum can occur. The endpoints are already given in this problem, that's -6 and 12, so we need to find those critical points. Critical points are where the derivative of the function you're trying to maximize or minimize is equal to 0. So in our case, it would be where g prime of x is equal to 0. as we talked about on the previous parts, we can state that g prime is equal to f of x. Therefore, we're also trying to find where f of x equals 0. And that's the one we're going to use since that's the graph that's given to us. So between -6 and 12, the values of x where f of x equals 0 occur at 0 and 6. So it looks like we have two critical points that lie in the interval from -6 to 12. So let's go ahead and set up our candidates test. So I'm going to make a table of x values, and I'm going to plug these x values into my g of x function. Once again, we test our endpoints of -6 and 12, and also our critical points of 0 and 6. We're now going to plug these 4 x values into the g of x function, and remember g of x is defined as the integral from 6 to x of f of t dt. So when we find g of -6, we are finding the integral from 6 to -6 of f of t dt. Now once again, I usually switch these bounds and make the integral negative, but you can see between 6 and -6, I have the same two semicircles. One happens to fall below the x-axis and one falls above the x-axis, so they simply cancel each other out. So that integral will equal 0. The next integral would be the integral from 6 to 0 of f of t dt. That one I would think about switching the bounds and making it negative. And we actually already found this answer in a previous part, and we got an answer of -9/2 pi. That was this semicircle right here from 0 to 6. And then making it negative. And the next integral then is the integral from 6 to 6 of f of t dt. Now remember, when those upper and lower bounds are equal, that integral is simply equal to 0. And then the last integral would be the integral from 6 to 12 of f of t dt. That's that triangle that we talked about in the previous part, 1/2 base times height, and we got an area of 9 for that piece. Okay, so now as we look at these, we need to make sure to answer the question, which was find the value of x when g attains an absolute minimum. And as I compare those answers, 0, -9/2 pi, 0, and 9, well, the minimum value would just be that one negative answer. So therefore, you would want to write a final sentence that says g attains an absolute minimum at x equals 0. So that's it. Question number 4 from the 2025 AP Calculus AB and BC exams. I hope you found that helpful, and go ahead and check out the other FRQs from 2025.